Hey guys, welcome. This is our 3.5 video and we are going to get started here. It says parallel lines and triangles, and our objective today is to use parallel lines to prove theorems about triangles, to find measures of angles. That's supposed to be an angle. Like, angle. Remember? Acute. Alright, anyways, of triangles. So, let's go ahead and get into some stuff. Woohoo! Alright, our first postulate, make sure you write the picture, the words, everything in this box, the whole box, and label it parallel postulate. Again, postulates are things that we take as given truth, and here it says through a point not on a line, there's one and only one line parallel to that given line. So here's line L, and if I had that point, the only line that would be parallel to it would be this line. There would be another line, because if I drew another line, look, it would eventually hit this line, and parallel means it cannot hit. Let's keep moving. The sum of the angles of a triangle is 180. So you might have heard this already before, but this is true. If you add up all those angles, A, B, and C, you're going to get a surprising result that they add up to 180 degrees. We're going to take a look at something in class about that, but I don't want to, any spoiler alerts or anything like that, so we'll go ahead and wait to see that in class. Alright, pause. Okay, next, this I would like you guys to write as well. An exterior angle of a polygon is formed by the side and an extension of the adjacent side. So here in the picture below, all the angle ones are exterior. This makes sense. Exterior means you're on the outside, and this is on the outside of a triangle. This is going to be really important because you can kind of see this theorem that's going to be coming up in a second. For each exterior angle of a triangle, there's two non-adjacent interior angles, and we call them the remote. If you think about it, what is a remote? A remote is like, I'm sitting at my couch and I'm trying to change the channel. I do it remotely. I don't have to go up and actually touch the TV. I can just sit back with my remote, so I'm not right next to it. So notice down here in each of these triangles, 2 and 3 are the remote interior angles. This is an interior angle, but it's right next to it. It's like you're next to the TV. It's right next to the exterior angle. So these are the remote ones. They're further back. 2 and 3, remote. Further back. 2 and 3, notice, not right next to it. Further back. Okay, so draw those pictures. Let's get to the last theorem, and we're already here, so let's just go ahead and write this down. I love how it says take note. It's like, what should I do? I should take note. The triangle exterior angle theorem. This is kind of an interesting one. We'll talk a little bit more about it, but it says the measure of each exterior angle of a triangle, so this guy, number 1, equals the sum of the measure of its two remote interior angles. So 1 should equal 2 and 3. I wonder why this is. I bet you we could figure this out, because there's probably relationships with 180. You will prove theorem 312 in exercise 33. Okay, let's get to some examples. Okay, let's get started. We have 2 triangles here. I almost did 3, but there's 2. In the diagram to the right, x equals 78, y equals 102. What is the value of z? Well, first of all, I could actually find x and y without your help. Thank you very much, computer. Because I know a couple things. First of all, if this is 43 and 53, I could write an equation that says 43 plus 59 plus x, that's a triangle. So it should equal what? 180. And if you don't believe me, I'm going to use a calculator right now. 43 plus 59 plus, they told me 78, right? Look at that. You see that? I add them all up, I got 180. That's because it's the triangle sum theorem. The angles of the interior add to 180. And then what do you notice about x and y? They're a linear pair. So if they're a linear pair, they must also add to 180. And then last but not least, we have this triangle, and those angles should add to 180. So I should get 49 plus 102, which was the value of y, plus z equals 180. And we just go ahead and calculate. 102 plus 49, that gives me 151, plus z equals 180, and then we just subtract it. And we get a beautiful answer of z equals 29 degrees. So again, we are going to be using this for the rest of our time in geometry. This is a foundational piece, the triangle sum theorem. Let's move on. Okay, this one, super easy. What is the measure of angle 1? Well, there's two ways I could do this, right? I could add 80 plus 18, find this angle, and then find what it's supplementary to. But the triangle, or the exterior angle theorem, states that this angle, angle 1, is going to be equal to the two remote interior angles. So I literally just add these two up, and I will get my answer. And angle 1 is going to equal 98. Now let's think about this. This makes sense because if this is 98, this angle right here is going to be 82, right? These have to add up to 180. And then these are supplementary. That's why this works. It's kind of like the congruent supplements theorem, just shifted for a triangle. Okay? But that one, nice and easy. Last one. Okay. In problem 3, we found angle A by using the triangle exterior. Can you find angle A without using that theorem? Okay, so we didn't actually do that, but we could have, right? So how could I find angle A, and this is x, by using something other than a theorem? Well, we could use, instead of the exterior angle theorem, where we would have done 30 plus x equals 80, well, we could use supplementary. So this would be 100 in here. And then I could say 30 plus 100 plus x would equal 180. And that would be using our triangle angle sum theorem. And so that would be 130, subtract, we can do this in our head, that's 50 degrees. Okay? So we could do this method, or they showed in the previous example, which we didn't do, was the triangle exterior angle theorem, which would add the two remote interior and set equal to 80. Either way, do we get the same answer? Yeah. Alright guys, over